So let's look at visible light today then. So firstly, let's look at all the colours that make up visible light. So we've got red, orange, yellow, green, blue, indigo and violet. I'm just going to underline red, green and blue because I want to talk about those ones specifically in just a minute. Now this visible light is an electromagnetic wave. It's the one that you can see with your eye, and it has a range of wavelengths from about, well, for red it's about 700 nanometers, and then violet goes all the way to about 400 or so nanometers. Okay, so that's the wavelength of light that you can see, and again, because it's an electromagnetic wave, it travels at the speed of light, which is 300 million meters per second. So I've underlined red, green and blue. That's because those are the three primary colours. Okay, the primary colours. What do we mean by that? Well, if you wanted to get to orange, yellow, indigo or violet, or any other colour in visible light spectrum, then you can mix together the colours. Okay, so you can take red and green, you can mix it together, or you can take blue and green, mix them together, and you can get a range of different colours from just mixing together the primary colours. So what happens then if you take all of these colours and you mix them all together? If you take red, orange, yellow, green, blue, indigo and violet and you mix them all together, well, you get white light. Okay, so white light is made up of all of those different colours. Now what I'm going to do is I'm going to shine some white light on this red apple. Okay, so I'm going to shine white light, and the way I'll represent white light is just by drawing arrows for all of these different colours in the visible light spectrum. So we've got red, okay, so that's how I'm going to represent white light, just by taking all of those colours and mixing them together. Now the red apple is red, yeah, that's obvious, but the red apple is red because it only reflects the red part of the spectrum. Okay, so if I shine all of these colours, at it, in other words I shine white light at it, then the red apple will only reflect the red light. And that's why it appears red. Okay, an apple is opaque. That means that light does not travel through it. You can't see through it, basically. Okay, it's opaque. And the colour of opaque objects depends on which wavelength of light they absorb the most and which wavelength of light they reflect the most. So in this case, this red apple will absorb orange, yellow, green, blue, indigo and violet light and reflect only red light. Okay. Now, translucent objects are slightly different, okay? So here I've got a translucent green screen, or a transparent green screen. Okay, so you can think of transparent as being see-through, and translucent as being partially see-through, okay? So if I go ahead and shine white light through here, okay? So I'm just going to go ahead and just copy all of these. Okay, let's shine my white light through this green translucent screen or transparent screen. What do you think, what colour is going to come out of the other side? Well, this green screen will absorb red, orange, yellow, blue, indigo and violet and let through just the green light. Okay, so green light will be able to pass through it. That's why everything looks green through this green screen. However, if I took the green translucent screen and I held it in front of the apple, then the apple will actually appear black. Why will it appear black? Well, because the red light the apple reflects gets absorbed by the green screen, letting through no light at all. And your eyes will perceive no light at all as being black. Right, so that's visible light then. I will see you in the next video.